is to reach as many people as possible throughout Karnataka in the easiest possible way. So this is the easiest possible way. You don't have to move out of your house, and at your convenience, you'll be able to listen to many topics, lectures on many topics. So thereby, you'll be able to gain at least some knowledge about different topics, different subjects. So which is very essential nowadays because it will help you in teaching and also in research and communication and so on. That's our idea. So in this endeavor, we have been helped by faculty members from colleges, universities, and also research institutes like ICTS, IISc, Raman Institute, IIA, and so on. So very thankful to them. And we have conducted talks on various topics from the microphysics to macrophysics, all the way from nanotechnology to cosmology. And with wide coverage, we have been able to accomplish. And we are very thankful to the speakers and also the participants. Today, we have a very distinguished geologist from Karnataka, who is now presently visiting USA, Professor Nagendra. So he is going to tell us about seismic profile seismic profile analysis, and how to integrate geophysics, how it integrates geophysics and geology. So before I request him to talk about this topic, I request our General Secretary, Professor Nagaraju, to introduce him briefly. Over to Professor Nagaraju.
Thank you, sir. ಪ್ರೊಫೆಸರ್ ನಾಗೇಂದ್ರ ಅವರನ್ನ ಇಂಟ್ರೊಡ್ಯೂಸ್ ಮಾಡೋದಕ್ಕೆ ತುಂಬಾ ಖುಷಿ ಆಗುತ್ತೆ. ಅವರ ಪ್ರೊಫೈಲ್ ನೋಡಿದಾಗ ಸಾಕಷ್ಟು ಎಷ್ಟು ಹೇಳೋದು ಎಲ್ಲಿಗೆ ಬಿಡೋದು ಅನ್ನೋದೇ ಗೊತ್ತಾಗ್ತಾ ಇಲ್ಲ. ಇನ್ನೊಂದು ಖುಷಿ ಏನು ಅಂದ್ರೆ ಅವರು ನಮ್ಮೂರ ಹತ್ತಿರದವರು, ಒಂದು ದೊಡ್ಡ ಊರು ಅವ್ರದ್ದು ತಗಡೂರು ಅಂತ ಹೇಳಿ, ಹಾಗಾಗಿ ನನಗೆ ಇನ್ನ ಜಾಸ್ತಿ ಖುಷಿ ಆಗುತ್ತೆ ನಮ್ಮೂರಿನವ್ರನ್ನ ನಾನು ಇಂಟ್ರೊಡ್ಯೂಸ್ ಮಾಡ್ತಾ ಇದ್ದೀನಿ ಅಂತ. Sir, Professor Nagendra obtained the first rank in MSc Marine Geology, and he completed his PhD program in the year 1989 from University of Mysore. And of course, Dr. Nagendra, MSc PhD, FGS, distinct awards like FGS, FPMS, FMS, FPS, like that. And UGC Career Awardee, TNMF awardee, like many awardees have been given to Professor Nagendra. That's why we are proud of him. Though he has worked in other states, but he has got many number of distinction awards and other mentions. Of course, project investigators of UGC, DST, NRSA, BRNS, DST, ILTP, CSIR, MHRD, etc. He has served as Emeritus Professor after completing, formally retired from Department of Geology, Anna University. He served as Emeritus Professor for 2 years in the same parent university, Anna University, and Adjunct Professor CNS Mahe, Manipal, UGC, SAP, and international collaborations like US, Russia, Malaysia, Mexico, etc. And he was worked as additional control also in the same university, that is Anna University. And he was the director, Society of Cooperative Society, AU, Chennai, geological scholar, and citation about 1,500 and above. And he is a fellow of various academics. The number of other awardees and total number of papers he has published more than 250, and he has published 4 books, and he has been the editor for more than 3-4 journals, and international conferences he has attended more than 35, national conferences more than 110, and invited talks about more than 100. And PhD guidance, he has guided more than 12 students, and he is a joint editor of JIAS, and now presently the member of KAS also. And in fact, his biodata is very, very good. We are proud of him, and he has accepted to give a talk on seismic profile analysis, integrating geophysics and geology for subsurfaces exploration to our members, that is KPA members. We invite you, sir. Now it is your presentation, sir. Thank you, sir. Thank you
Thank
and
you very much, sir.
welcome. And
Thank you,
all the
sir.
other members also, I think we will be able to listen to him. Thank you, sir.
Okay.
Thank you, sir. ಸೊ ಎಲ್ಲರಿಗೂ ಭಾನುವಾರದ ಸಂಜೆಯ ನಮಸ್ಕಾರಗಳು. ನನಗೆ ಈ ವೇದಿಕೆಗೆ ಬರಲು ಆಹ್ವಾನ ಕೊಟ್ಟಂತಹ ಪ್ರೊಫೆಸರ್ ಕಾಗಲಿ ಅವರಿಗೆ ನನ್ನ ಧನ್ಯವಾದಗಳನ್ನು ಹೇಳುತ್ತಾ ಮತ್ತು ಪ್ರೊಫೆಸರ್ ನಾಗರಾಜ್ ಅವರು ನನ್ನನ್ನು ಈ ಸಮೂಹ ಇದಕ್ಕೆ ಭೌತಜ್ಞರ ಅಸೋಸಿಯೇಷನ್ಗೆ ಪರಿಚಯ ಮಾಡೋದಕ್ಕೆ ತುಂಬಾ ಧನ್ಯವಾದಗಳು. ಈ ದಿನ ನಾವು ಒಂದು ಭೂಗರ್ಭ ವಿಜ್ಞಾನವನ್ನು ಭೌತಿಕ ಶಾಸ್ತ್ರದ ತಾಂತ್ರಿಕತೆಗೆ ಸೇರಿಸಿ ಭೂಮಿಯ ಕೆಳಗೆ ಹೇಗೆ ಏನನ್ನು ಇರಬಹುದು, ಅದನ್ನು ಹೇಗೆ ನಾವು ಕಂಡುಹಿಡಿಯಬಹುದು, ಅದಕ್ಕೆ ಬೇಕಾದಂತಹ ವೈಜ್ಞಾನಿಕ ಸುರಿಗಳನ್ನು ಈ ಸಂವೇದನೆಯಲ್ಲಿ ಮಾಡೋಣ. ನಿಮ್ಮ ಈ KPA ಪ್ಲಾಟ್ಫಾರ್ಮ್ ಇರೋದಕ್ಕೆ ನನಗೆ ಬಹಳ ಸಂತೋಷವಾಗುತ್ತಿದೆ. ಸೊ ಮೈ ಟಾಕ್ ಇಸ್ ಟುಡೇ ಆನ್ the integrating geology and geophysics. As we know, geophysics gives a very technical support to understand the various information to look for the Earth's surface and subsurface. So in the subsurface, it is very difficult for us to go physically to review the information available for various geological environment. So this geophysical physics light, particularly, we apply the electrical resistivity method, gravity method, magnetic method, and seismic prospecting methods. So here in this talk, we are concentrating on seismic prospecting methods, particularly on seismic profile analysis, which are very much applied in the hydrocarbon industries, that's petroleum industries, to look for hydrocarbon deposits in the subsurface. What is the subsurface is? The subsurface, which gives you the information about what are the different constituents present in the Earth interior, which has formed 4,600 million years back. So this, we're trying to create the history which you're not able to see physically there through this geophysical technique. So the geophysics is an innovative approach to understand Earth subsurface analysis. So this has a various applications, particularly when I'm talking about petroleum exploration. Petroleum exploration goes with a very short term called SMART. SMART is nothing but there should be a source rock. None of us we have seen how the petroleum deposits occur in the subsurface. We have seen only the petrol which comes to our automobiles. So this hydrocarbon industry always looking for a SMART analysis. SMART analysis defines as one is source rock. There should be a source for generation of hydrocarbon, that is crude oil, petroleum deposits. And there should be the migration. Once it has been formed, it has to migrate to a very comfortable and congenial locations to store that deposits. That is goes to the migration. And the migrated material should accumulate at one bowl, that is called accommodation. So accommodation, migration, and source rock, it all should available at a place where it get the completely porous material which holds this material called reservoir rock. So when you have all these four phenomena here, that should be properly sealed by the nature, that we call as a trap rock. That is called seal rock. So the SMART process in the inside the earth, below the earth, is one of the reason to get into these hydrocarbon deposits, which we are exploiting today in the various oil basins. Particularly, we are getting more in the north, northeast, and the western part of India and southern part of India. All of us we know we get a major oil fields in Bombay High. So Bombay High is the definition which we called. It is discovered near the magnetic anomaly. In magnetic anomaly zones, these hydrocarbon deposits have been accumulated that we are exploiting since quite many decades. Similarly, we have in the northeast, first oil deposit in India has been identified and explored in Digboy in Assam. And also we have in the southern India at Krishna Godavari Basin in Andhra Pradesh and Kaveri Basin in Tamil Nadu. So this geophysics is a major part of a analysis in hydrocarbon industries to look for the subsurface. So geophysical technique, particularly the seismic techniques, is also referred as a subsurface ice. it's subsurface ice, which takes the subsurface camera and trying to understand all the informations with the help of seismic signals. Besides this, we also use the geophysical techniques in groundwater detections, subsurface water analysis, so where the groundwater occurs, and map how much water it occurs, at what depth it occurs, and what type of water it is, and what terrain it occurs. Is it in a subsurface of a hard rock to drill, or is a very soft rock to remove it and take the water? And also we have a groundwater has a connectivity with the surrounding zones through a fractures or a joint plane through which various our industrial effluents reaches to this aquifer. Aquifer is nothing but a water porous media. So that where you can have a contamination assessment. So contamination assessment also can be analyzed with the help of this electrical resistivity method. So when you come to these engineering applications, so as we know, we are growing like a very fast track country where a lot of new buildings, new adventurous structures are constructing. Recently also we had a Chennai bridge and atoll tunnels, many land, various railway tracks and bridges which are constructing metro where we need a strong foundations. Again, strong foundation is risk as to go to the below the earth surface. How much below, depending upon the magnification of the structure which you are erecting on the surface. So for that deeper part of the earth crust to understand, we need this geophysics. So here we use both electrical methods and seismic method. Electrical method can able to restrict limited to a subsurface at a very shallow depth, whereas in the seismic, which will go to the deeper part of the earth crust. So in all the foundation investigations, the geophysics will be applied to understand the subsurface. Particularly when the metro projects, when they're digging it, various subsurface, the sewage lines, electrical lines, so many connectivity materials are there that can be reviewed with the help of the geophysics. And also we use called GPR, ground penetrating radar. Similarly for tunnel planning, landslide assessment. So very frequently we hear whenever the rain approaches, when the rainy seasons, so this will go for a landslides. Land slips down with approach the gravity. Why it slips? Because of the rock and soil will be completely porous with the wet water particles enter into these soils. That pore pressure expands the soil and causing the slides. As the slides, gravity pulls down. So this also we can understand with the help of this, the many electrical resistivity survey. Similarly, infrastructure development like road connectivity, rail connectivity, and the different town planning and other things where this geophysical constraint is very important to look for the subsurface view environment to go for a type of a decision of a type of a foundation, whether it is called the bell foundation or ladder foundation or the how much depth, particularly in nuclear projects in the waste management landfills, we need this type of a techniques. And come to the environmental studies, waste site characterization. That is nothing but a landfill constructions, particularly in the nuclear industries, nuclear thermal power plants. After completion of the nuclear minerals positions, that waste has to be dumped because it takes a equal time to get into the normalizing the minerals. So in that connection, that radioactive minerals should not get dispersed to the earth surface so that we lose the biotic world and it will be harmful to the life. So we need to identify locations of landfill where there is no percolation or no escaping of these nuclear waste radiations to the other part of the zones so that it will be safer to the life on this planet Earth. Geological hazards, that is coastal hazards, fire hazards, flood hazards, so that we can able to look for what type of a mechanism which we can build near the hazard prone areas and trying to understand, we use this geophysical technique. Carbon sequestration. Nowadays, we talked about the global warming, climate change. So where this atmospheric carbon dioxide to be captured and try to store in the subsurface rocks so that it will not emanating to the atmosphere for the climate change. So that this is a long-term storage mechanism which can also be able to do it. So like this, many applications useful for this, the geophysical, the information. Particularly when you're looking at subsurface, we look for interior of the earth. interior of the Earth. What is there in the inside the Earth? How far, how much depth we have entered into the interior of the Earth using this seismic. And also we have a knowledge about earthquake, how the earthquake it happens. During the earthquake, what energy which releases. So why the different locations, how to identify the earthquake zones, we use these seismic waves. So besides these things, so this geophysical technique also uses for exploration of metals, non-metals, and coal deposits, the various types of minerals and other resources which is required for the sustainability of the life on the Earth's surface. Now, when you see what is there in the subsurface so far, with the help of this geotechnical and geophysical and other parameters using, we have reached almost 6,371 kilometers center of the Earth to understand what are the materials available here and what are its conditions, how this will be acting on the Earth crust. So the surface, what we are looking is an Earth crust. So this Earth crust having almost 5 to 70 kilometers thick. Sometimes what are the geological terminology we talk, it goes beyond imagination. 70 kilometers thickness of the hard rock which is present on the Earth crust where we are living. So entire our life is on this one. And this entire Earth crust top surface, top part of the Earth section contains two units. One is ocean continents where the ocean water is there. Below that, there is a land surface. That's ocean continent. One which is exposed what we are looking today and what we are living here. The hills, valleys, and undulated topographies, ghats, etc. The crustal continent or this oceanic continent and continental continent. So this entire unit which we called as lithosphere, which constitutes a solid material. How we have understood this particular phenomena? So what are the constituents are present in, what are the different type of rocks which are present, which makes the more stable cratons. So the P and S waves, primary waves and secondary waves were applied here. The primary waves, as we know, it travels in all the three media. S wave travels only in solid media. So using these velocity variations, so 5 to 7 kilometers speed, which travels from the surface to the subsurface, and almost 3 to 4 kilometers per second, which travels in this crustal part. So this continental crust and oceanic crust, which has been identified, and various types of hard rocks and soft sediments which are present in these units. When you go below this unit, when we reach us to a called asthenosphere, which constitutes a partially melted material, which will be acting as a lubricant over this surface crust. So below this asthenosphere, we have called as a mantle. So it is almost up to 2,850 kilometers thick from the surface. This area has three different sections which have been understood with the help of seismic waves, that is upper mantle, transitional zones, and lower mantle. Upper mantle has been 7.5 to 8.5 kilometers per second. The S waves has 4.5 to 5. Similarly, the transition zone 9, it increases. So this velocity increases will be a reflection information for us to see what type of material it is, what type of rock it is. So this analogy has been applied to get these seismic profiles. So that seismic profiles decoding and connecting to the analog to understand what is at the subsurface. So this layer, this entire zone contains a thick silicate rock layer below the crust, and it moves slowly, drives, because this is a partially melted, this is solid part, this is almost the silicate rocks, which is a liquid. So entire Earth is sitting on this, which triggers for this crustal movement. It movements due to convection currents. So convection current is the one which creates a continuous loop. The warm fluid rises and cold fluid sinks. During this continuous movement, which induces this asthenosphere to give a stress onto this Earth crust, hence it starts moving on the different directions depending upon the stress causes due to this convection currents. So this has been another one zone has been identified. So this zone has been named as the person who was identified for Gutenberg, it is named as Gutenberg discontinuity. This is Moho discontinuity. Below this lower mantle, it is called core. Core again, the core is outer core has a liquid which is almost 2,200 kilometers thick, which is a P waves which travels because it's a 8 to 10 kilometers, whereas S waves will not travel. It reflected back. So that is the one information. So there is something change in the subsurface at this zone, which is a more of a liquid iron and nickel. This zone is responsible for generating Earth magnetic field. So below this outer core is called inner core. It is at 127 kilometers thick, reaching to the almost 3470 kilometer in the entire core. Here again, we have a solid, denser center which composed of iron and nickel. So here you can see the P waves, that is 11, not 111, 11 and 11.5 kilometers, 3.5 and 4 kilometers per second. So here we use the seismic energy, seismic waves attributes to understand the subsurface constituents as internal structure of an Earth. So as we know, temperature increases with respect to depth. How much? For every kilometer when you go below, there will be a 30 degrees temperature increases. So you can imagine what may be the temperature at this age, at this depth, and what is the temperature at this depth. So this with basic constituents and fundamental information, what we understand is the outer shell is broken into rigid plates. As I told you, there is a liquid in the mantle. Astrosphere is a partially melted, and upper you have a solid. So due to this convection currents and Earth rotation, the outer shell part is broken. Yes, sir.
Sorry to disturb you. ಈ ಹಿಂದಿನ ಸ್ಲೈಡ್ಗೆ ಹೋದ್ರೆ 7,000 approximately 7,000 kilometer ವರೆಗೂ ಡೆಪ್ತ್ ವರೆಗೂ ವೇರಿಯಸ್ subsurfaces have been identified.
Yes, sir.
ಅಂದಾಜು approximately. ಅದ್ರ ನನ್ ಏನ್ ಕ್ಲಾರಿಫಿಕೇಶನ್ ಬೇಕು ಅಂದ್ರೆ ಅದಕ್ಕಿಂತ ಕೆಳಗೆ ಇಲ್ವಾ ಏನಿದೆ ಬಿಯಾಂಡ್ ದಿ 7,000 kilometers ಒಂದಾದ್ರೆ ಈ ಡಿಸ್ಕಂಟಿನ್ಯೂಟಿ ಅಂದ್ರಲ್ಲ, ಹೌ ಡು ಯು ಐಡೆಂಟಿಫೈ ಡಿಸ್ಕಂಟಿನ್ಯೂಟಿ ಏನಿರುತ್ತೆ ಸರ್ಫೇಸ್ ಟು ಸರ್ಫೇಸ್ ಡಿಸ್ಕಂಟಿನ್ಯೂ ಇದ್ದಾಗ?
Discontinuity ಇದ್ದಾಗ ಸರ್ ಮೆಟೀರಿಯಲ್ ಬಿಹೇವಿಯರ್ will be different. Liquid, solid, gas. So and viscosity of the materials will be different. So that reflected by your seismic energy reflection patterns. And below this 6,371 kilometers, there may be something, sir. So far, it has been understood the Earth center up to 6,371 kilometers.
ಅಷ್ಟೇನಾ?
Yes, sir.
Sir, in continuation of what Professor said, sir, how sharp is the demarcation between different layers, sir?
How short we, sir?
Demarcation between different layers. Like,
different layers, sir.
Is it a gradual changeover in the composition, or, I mean,
Sudden change.
Sudden change will be there?
Sudden change will be there, sir, because temperature changes, sir. Temperature and pressure changes at the depth, because once you go down, temperature and pressure changes. Due to that, the material composition changes.
So
ಟೆಂಪರೇಚರ್ ವಿಸಿಬಿಲಿಟಿ ಇಸ್ ವೆರಿ ಪೂರ್. ಅದೆಷ್ಟು ಅಂತ ಸ್ವಲ್ಪ ಮ್ಯಾಕ್ಸಿಮಮ್ ಮಿನಿಮಮ್ ಎಷ್ಟೆಷ್ಟಿರುತ್ತೆ ಸ್ವಲ್ಪ ಹೇಳ್ಬಿಡ್ತೀರಾ?
Sir, actually temperature, sir, what we talk about, we have to convert it, sir. What is the depth here into 30? At every 1 kilometer, 30 degrees increases. So 2,900 kilometers into 30.
ಓಹೋ, ಅಂದ್ರೆ ಅಷ್ಟು ಜಾಸ್ತಿ ಆಗುತ್ತಾ?
Yes, sir.
Oh my God.
Even whenever we go to the mines, sir, temperature increases.
30 degrees per kilometer, sir, per kilometer.
Yes, sir. Yes, sir. Yes, sir.
Thank you, sir.
So due to this phenomena, Earth outer shell, because of the moment, broken into rigid plates. The plate which we called as the complete astrosphere part and upper solid part. So when the Earth has been formed, it was like this. This is called Pangea. You see, all the continents what we are talking today was connected during that time when the Earth has been evolved. That is 4,600 million years back. So due to this, the outer core and movement of material which we called as plates are nothing but astrosphere and solid part of the Earth. So these plates move slowly, very few centimeters per year. Due to the heat driven, that's what I told you about convection current in the mantle. So this plate movement causes the formation of mountains, to rise the continents, oceans to shift from one place to another place, and also responsible for earthquakes and volcanic eruptions. So this creation of the ocean basins and mountain ranges, where you can see this, the one single land mass has been dissected into a number of land mass. Even if you cut these continents today, all these countries, and rejoin it, puzzling it, you may get almost approximately like this. So this is what we call it as continental drift. The drifting causes due to this, the inter hot heat-driven convection by the earth broken shells, plate tectonics. So this, the how this plate moves, this plate maybe one to one plate get collides, depending upon which direction it moves, which direction that force is acting at that particular time at particular locations, or it may get separated out. Due to this, or it may get sliding also. So leading to this, you will get a different plates. Here you can see Indian plate, the Somali plate, African plate, South African plate. Like this has been understood about how the earth was and how the earth is. So over the million of years, this all go with a million of years. Million of years, these movements have continuously reshaped the Earth's surface, and it is continuous. And formation of break into continents and various type of ocean basins. So when this was formed, only one ocean was there. That is called Panthalassa. Pangea is called landmass, and this one is called southern part called Gondwana, northern part called as Laurasia. So this part again has been separated out, and where the India has been got separated from Australia and Antarctica and Africa. So this is the one what the animation which shows to you what happened in 250 million years back. Since it's a continuous, I shown only one animation here, how the continents are dispersed from the one landmass. So this is in million years, and these are the landmass which get separated out. You can just see how the India has got separated from Madagascar and moving further and hits the North Eurasian plate and form into a Himalaya. So you can imagine the total mass which is moving in the speed and velocity and direction, which are all controlled by this subsurface environment. So that's why whenever you see, in India, you see Madagascar was together and which has been separated, the Madagascar from India 80 million years back. 80 million years back. And that's why you can see even today, when you go to the Western Ghats, we have more of a waterfalls. When you come to the Eastern Ghats, we have more of delta. So we have more of east flowing rivers, less west flowing rivers. So that also indicates how the land mass has been separated and making it spinning with respect to this earth dynamics. So whatever happened, whatever we are talking about earth origin until today, this has been as prepared a time frame. This time frame prepared based on the available evidences on the surface, on the subsurface, and both in organic material and inorganic material. And this is also used using isotope analysis, one which we have very good institute in India called Physical Research Laboratory at Ahmedabad. They use uranium dating, potassium argon dating, carbon dating, many techniques they have in their laboratory. So we can take out this subsurface material and trying to understand over the years of the ages. So I identified and trying to recapitulate it, what it might have been happened in the earth since the formation of the earth. You see here, up to 550 million years. So there was a big change, which called as the explosion of life, explosion of death. At the same time, there will be a, you see, death rate of organism, 85%, 70%, 95%, 85%, and 80%. So much of destruction and constructions, both is happening at. So all of us, we know the Jurassic of past, dinosaurs. Dinosaurs, everybody knows, dinosaurs extinction. Dinosaurs have ruled the earth almost to 200 to 250 million years. That time, even the mammals was very submissive and cold-blooded animal. Subsequently, once the dinosaurs got extinct, which has been emerged as a mammals. So why this dinosaur extinction, everybody knows. Either one is meteoric impact, other one is continuous volcanic eruption, which causes the not congenial environment so that it has got extinct. So this is what we refer as mass extinction. So when the man came to the earth almost 1.8 to 2 million years back. So 2 million years back. So based on this time scale has trying to give us an information how it is available. So you may ask, how do we know all these organisms? Certain organisms were preserved in the rock. After death and decay, the hard parts get preserved in the rock and gives us what we call as fossils. So these fossils explains to us how it would have been lived and what time it has been lived, so that we can able to review it with the help of these available signatures and understanding the earth environment. How the earthquake takes place. So when you say earthquake, when the blocks of the earth crust suddenly slips due to these convection currents, the slip past one another along a broken line. That broken line, what we call as fault, and it's called fracture plane. So when it's a sudden movement, which usually triggers by gradual buildup of stress as earth tectonic plates is forced against each other, which strucks the continents one to one or it separates. When this causes stress exceeds the strength of the rock along the fault, the rock breakups, slip, causing the rapid release of this seismic energy, that is elastic energy, in the form of seismic waves that shakes the ground. That shaking the ground, what we call as earthquake. So during this shaking, there are chances of erupting volcanoes also. So this earthquake happens both on the continents and in the ocean basins. So whenever it happens in the ocean basin, slip of these continents, we experienced tsunamis in 2004. So where the water waves get rises due to this. So keeping this complete data set with available unit, the historical records of various earthquakes happened in the different part of the country and in India. And also now we have a lot of seismograms has been stations are available and GPS stations are available, which has been placed in different zones and prepared a seismic zone map of India. So we are very much the unit where you see there is no active at all. So this not much earthquake activities. It is called as a shield areas. These are all susceptible for earthquakes, susceptible earthquakes. That's why we never felt not much of greater earthquake, only tremors and other things. Sometimes we might felt it. So this is the one which has been prepared by the seismic zones of Indian map. So this is San Andreas fault. This is what I'm calling fault, where the slipping of the continents. So how to bridge these two things? So bridging of the things, which we call understanding the seismic response to the known geology. Known geology. That means what is exposed on the earth surface. The physically available, we can go to. So if you go to the Chamundi, we call it as a hill. When you go to the Himalaya, we call it as a mountain. When you go to the Dehradun, we call it a valley. So we have a different geomorphological landscapes available. So when we go there, that we do what we call as always in geology, we call as field work. The field studies we will go, take the topography, slopes, rocks, rivers, vegetations, whatever the data available, which will be conducting and trying to understand that particular outcrop. So take the understanding seismic response to the known geology and trying to understand subsurface. And sometimes we need a more data for deeper foundations or a petroleum exploration, drill the core sample. As we are drilling for the groundwater, drill the core sample. Drill can go up to 2,000 meters, 3,000 meters. And there you can get the seismic energy reflections. Artificially, you generate the seismic energy and inject into the unit. So this ground truthing the seismic interpretations. And a typical geological control points using the well log, that is a neutron log or your alpha log. So many type of logging techniques available. Using that sonic log and calibration, we can understand what is the behavior of rock material in the subsurface. So later we can able to use 3D and 4D images. That image will be used to understand the rock layer framework, preparing a geological model. So any seismic data, first we have to acquire the seismic data. This has to be processing to the noise and working mechanism. Then we have to interpret the unit. So seismic data will be available. Interpretation has to be done depending upon the need, where this geological phenomena plays a major role. We need to identify what this seismic image has emerged out from this exercise, what it explains to us. From that, we can create a modeling, and modeling to be validated and refinement. What is happening today in oil industries of these called as API, acquisition, processing, and interpretation. What is this seismic profile is? It is a vertical section. It explains to us how these seismic waves are reflected, are refracted, are transmitted through the various subsurface layers. As we seen in the previous slides, subsurface have a different type of material. That's called heterogeneity, which reveals whether it is a hard rock, soft rock, whether rocks are horizontal, rocks are undulated, or rocks are broken, and what type of the structure which are present, is it a folded or fractured, and what type of fluids trapped in these zones can be understood from this seismic profile. So this technique is applied for petroleum exploration. So a geophysical is a geophysical technique. It uses artificially generated seismic wave from the surface and from the ocean water surface to the ocean continent, and creating a seismic waves. We image the subsurface structures and rock layers. The concept is the analyzing the travel time, how much time which has been traveling in the media, what is the amplitude and frequency. These characteristics are reflected and refracted seismic waves map surface and giving the information to us. So this is a non-invasive exploration capability, high resolution imaging capability, wide range investigation depth, and quantitative subsurface characterization. So all oil industries, I have visited many oil industries. So in ONGC, there is called as GeoPEC, where they have a high-end, high-resolution software to process this seismic data called seismic workstations. So fundamentals of physics principles is used in seismic as wave propagation, P waves, there is a body waves and surface waves. Here we use body waves to understand about this, the behavior of the different rock attributes. That is primary waves are compressional waves, S waves, and surface waves, of course, it's only on the surface use, which will govern by the Snell's law, because you're all physicists, you know these things. So just I put one slide to explain what seismic is. So this controls the reflection and refraction at the different layer boundaries. So and this, using these coefficients, we can find out at up to what depth which has reached and when it has received. How it receives, the one is injecting the seismic waves or generate the seismic waves and transmit to the subsurface, and you have a mechanism to reflect that wave to receive through geophones on the surface. So at the time frequency which will be understanding, trying to look for the subsurface environment. So what it explains to us, seismic reflection represents, it will be changes based on acoustic impedance. So this change in the velocity or density. So lithology is nothing but a rock type and fluid type. What type of fluid? Is it a water or a oil? So this can be understood based on the change in the velocity pattern. And wherever the lithology occurs, wherever the rock change occurs across the strata surface, as we asked earlier, unconformities. Unconformities break in formation. That break in formation is the one depending upon different composition of materials, which will be occurring on the bed boundaries. It will be laterally changes with respect to the deposition environment. Deposition environment here is, it may be a river environment or a marine environment or desertic environment or glacial environment. So this resolution of seismic resolution resolves the large scale strata units, which will be conducting to kilometers together and trying to analyze what it is. It has been done even online surveying, basic principles. Seismic waves are refracted by, you might have seen, they will hammer the surface. They will take a big sledgehammer and make the creating a seismic waves, discontinuous surface as they travel downwards. A simple experiment we're all done in the younger ages. When you go to the lake water, you take a stone and throw the stone onto the water surface. When the water strikes, you can see the rings, the seismic energy which develops. The similar analogy here, how the seismic energy which travels and creating seismic dispersion from the center point to the peripheries. So based on this seismic wave travel, you understood, if it is a travels 3.6 km per second, that rock is a soft rock, which we called as shale. Shale is nothing but a clay rock. And 4.2 km per second, that will be normally which will be travels in a sandstone rock, and everybody knows this sandstone which you are using for construction, and 5 kilometers per second, which called as a limestone rock. So what we are using called uh, limestone materials used as a calcium materials. So the difference between seismic section and our geological sections are seismic sections are scaled in a vertical direction on the basis of travel time and seismic waves. A geological section which we draw based on the depth measurement down from the surface. So we will try to take the vertical section and trying to understand what are the constants present. Seismic wave gives you the seismic analysis which travels in a different media. We can able to fix up what are the different constants are present. What are the patterns? How to identify? You see here, when seismic pattern images comes out after seismic analysis, you will get a different type of configurations. It may be a simple or a parallel, subparallel, or a sigmoid, oblique, or complex oblique type of unit, or it may get like this. So these are all reflection which completely mirrors the subsurface, mirror surface. Or sometimes you may not get anything. It's called chaotic, or it may be contorted, not continuous. So this, what is the use of identifying this reflection pattern? So we look for, geologist looks what type of sediment supplied in that area. That can be the interpreted, how much rate of subsidence here, what is the change in sea level, water energy, water depth. So these can be decoded from these seismics. So whatever we do in this, that has to be decoded to understand the subsurface environment. See here, this is a seismic. You see, these are the seismic sections. This has been obtained from our seismic analysis. So what is these different lines, mounts, and other things with respect to depth? So this has to be translated to see whether it is a overlying, is it a sitting over the surface, or it will be under the surface? Is it a shelf edge? So this has been translated and redrawn like this to the scale and identifying whether it's a on-lap terminations or down-lap terminations, truncated reflections, or truncation surfaces. When you move from the land to the ocean or land to the subsurface, how the material has been done. So these are all happened due to this plate tectonics. So what we are looking since the Earth origin, so the various types of events have happened. This event has been reflected in this type of environment, which you're not able to see in a physical appearance. So that we are looking for the seismic sections and trying to translate it how the materials are present in the unit and what position it is lying on that. Based on that, we can try to see this is called, if it's an erosion surface, that is materials have been removed by the force of water activities and wave energies. And is it a top lap, or is it a down lap, or an on lap? So by looking these structural patterns identified from these seismic sections, we can decoding it and trying to look for analysis. So then we'll give an affiliation to that. What is an environment? What may be the age for these things? What type of material may be present in these? So all these things can be able to address in these issues. So as I told you, reflection configurations we have a deflection configuration, whether reflections are continuity, seismic reflection I'm talking here, amplitude, frequency, and internal velocity, and how it appears, and what are seismic phases. So defining these factors, we can go for reflection configuration. We know the subsurface, the rock patterns, how it might have been formed, and what type of the topography or the surface which present in the subsurface, and what is the fluid contents. Continuity, if you get it, whether it's a bedding continuity or deposition process. Amplitude talks about velocity, density construct, bed spacing, fluid content. And reflection frequency talks about bed thickness, fluid content. Internal velocity gives you estimation of lithology, porosity. As I told you, any oil industry smart, that porosity has to be identified. And ultimately, we go for gross deposition environment or sediment source or geological setting. So this is the one you see how this seismic waves has been translated using this picture and trying to identify this acoustic impedance and trying to recapture it by making it a 3D model by looking these lines. Each lines will explain to you the subsurface geological environment. So how is exposed part of the shelf? Is it a paleo delta? Once it was a delta, Now it is the subsurface. Once it was a river water, it has been considered inside. Many times we talk about the existence of subsurface river. How to analyze the seismic sequence? Seismic sequence, what we get like this. Once we get it, this reflection continuity, we can a typical unit, we need to affiliate it what it is. That is the upper boundary of the constituents. And so if you get like this, it will be a top lap. You can see this is a top lap. It is a unit is abducting to the surface of the layer. And this is concordant. And this is erosion. When you get undulation surface. So this has to be translated from these sections. That is possible in the workstations. And this yellow line represents the boundary, that's a solid line. So in the lower boundary, you have again, you see the on lap, and down lap. It's a coming from this end. It is a down lap. This is on lap. So keeping this, we can find out the ocean constitute ocean morphology. What is there in the ocean? So this is seismic section. You can see here. This is a reflection pattern which comes to the workstation. What to be done from this section? This we are getting from the geophysical methods. So this has to be translated using the geology. Then only this will become a usable material for us to go for various applications of what are the objects we are doing it. Trying to identify the what is this line, why this is thick line, thick black, why it is feeble, is it a continuous, is it a discontinuous? As I have shown you in the previous slide, is it a downlapping or is it a uplapping? See here, this is the one. Trying to mark like this and decode the information and trying to analyze, yes, this may be a big basinal structures present in the subsurface. So then we go for a drilling and trying to take the core samples, look for what type of material is it. Is it a very susceptible zone where we can look for a petroleum deposit? Similarly, you can see another slide here. So you see here, as we told unconformity, break-in sedimentation, these materials are different, these material compositions are different. So because of the variation in the composition which we use from the reflection patterns, so you can see how it is moved. So that is the way we're trying to address the when it might happen, how it may happen. So these informations will be validating in the surface also. So one of our research area on the land surface there has been done by ONGC, where you could able to see what are the different type of materials present in the subsurface which are seen in the surface. So seismic data acquisition, how to acquire this data? Data acquired on the land surface. There will be a recording truck using the short hole explosives, dynamic explosions, how much explosion, how much cartridge, and how much depth of information you are looking for this particular project. We need to do this exercise. So using this dynamic explosives or vibrosis or sledgehammer or weight drops, making this after, as we had discussed earlier, the time of injection, travel time, and receiver time. Each geophones are receiving this reflected unit and gives a seismic pattern to you. So which will give you 3D, 3D, 2D, and 4D or multiple components. So similarly, it will obtain from the oceans because ocean water and ocean crust. So here they use called air gun. Air gun is the source of shock waves. Compressed air is more environmental friendly than explosives, so that it should travel in the subsurface path of reflected waves, whether it is a soft rock or a hard rock, whether it is a porous rock or an imporous rock. Is it a fluid? What type of fluid it is? Is it a gas? So this detection can be interpreted. So again, these reflected waves will be received by placing the hydrophones. So there are up to 3,000 hydrophones and a 3,000-meter cable can be placed on the ocean unit, and you can take these unit. So these are the land and seismic data acquisition. So this is a flow chart, how we do this, the seismic analysis. Collect the raw data, format conversion, geometry merging, noise editing, gain energy to come to a recovery of the materials, and what type of application statics we are using it, what for it is, then noise suppression, surface consistent amplitude corrections, deconvolution, that is pre-processing, velocity analysis, residual static corrections, then PSTM, stack PSTM. So ultimate goal of this particular exercise is transform the raw material which you obtain from the seismic analysis to interpret it. You see, this is the unit. So there are a lot of noise during the conducting this experiment. That is the seismic, either an engine noise or a sea waves noise, breaking of waves, weather changes, wind, sometimes root vibrations, heavy rainfall. All these things will be interference while getting the data. So conditions of the cathode of this seismic energy reflection pattern. This is a raw cathode. So you see, this is a noise. So noise gives the disruptions in the profiling units. So this will be done using our software once you get it. So it will be continuously doing as and when the drilling is going on in the ocean floor or in the land part. So subsequently, you see the same unit, noise removal by manual edit. When the noise removed, we get a good reflection patterns. And so this is again a common point, common midpoint, many source reservoir offsets, sample at the same depth, and trying to recover it. What are these lines? What are these? The lines attributes and what it indicates, what it interprets. So here another one seismic section, improvement. You see what we are not able to see here properly due to the many reasons of while doing the seismic analysis. So we get okay, there is a subsequent, a good layer is present here. What layer, at what depth it is, and what is used for us, that is a subsequent analysis. That's called improvement. Improvement of this seismic profile into this unit. So here one is called decontest. Decontest, you see the first layer of data, subsequently refined. The refined unit, it's a process of getting a refinement. That's called decontest. Finally, you make it a good, the amplitude and vibrations of velocity. You see here, what you are not able to see clearly here, we can see clear here and clear. This is a channels, paleo channels. That means once it might have been a riverbed, now it is in the subsurface. Or it may be a solution channels, or it may be a tectonic, the attributes. So we need to recognize what exactly it is. We cannot offhandedly can interpret these things. So it has to be collaborated with the multiple data sets to see what exactly its interpretation is. So this is one again, a deconvolution without decon, with the decon. See the difference of this the removal of noise and getting a high resolution data. So residual stack. So deconvolution is aims to enhance the vertical resolution of seismic data, compressing the seismic waves, wavelets, and removing the unwanted effects. Unwanted effects. So it helps to sharpen the signals and make the individual reflections clear and interpretative unit. See the difference here and difference here and difference here. So this individually of all this data, what we are looking has a significance in the subsurface. So here we are looking only a small picture here, which runs 2 miles together. So collect this entire data and trying to reinterpret it to the need. Velocity analysis, again, you see the velocity analysis, which indicates what are the geological changes with respect to seismic velocities, as we are seen in the internal structure of an earth. Pre-stack time migration. So you see here how this changes. So imaging technique, repositioning the seismic reflections, their correct subsurface locations in time and moderate velocity variations. And this flat deepening events focuses reflections, improving the clarity of the image. So because we are handling with the subsurface, which is not able to access for us, we need to do all these exercises. You see here, so these seismics or lines are different than this. Here we are not able to see anything. Here we are able to see. So then we have to attribute what exactly this particular thickness at this depth and what type of material it is. And also we have a techniques to see what geological age for it is. Is it a 10 million years, 20 million years, 100 million years, 200 million years? So keeping that one, we can go for a retrospective effect of what would have been present in the unit using our geological time scale. So this is another one, improvement of optical imaging of subsurface, zoomed gather, gain applications, brute stack that is more clear, that is called peer. So what we are reading from the seismic data, we are acquired, we are processed, and what we are reading. Reading is correlation of horizons. Horizons is nothing but a layers. We are correlating one layer to another layer from one depth to another depth, and any fractures or breaking surfaces present in that unit. Fault mapping. If there is a fault, definitely slice will be there like this, or like this, or like this. It may move vertical to the up or down or side. So we call it in different terminologies. So this shifting of these layers, it can also be seen in seismic what you have seen earlier. So generation of time structural maps, subsurface rock layers, mapping of these rock layers, and trying to understand the velocity, converting geophysical information into a geological understanding, integrate log data, drill data, seismic data, and regional understandings, local tectonics, evolve a meaningful geological models. That is where integrating the geophysics into the geology. So what we are doing is we have a 3D and 4D images. As I told you, we need a reservoir geophysics. Reservoir geophysics will help us to do the reservoir modeling and production geophysics. When you're exploiting the petroleum deposits, we need a more clarity because it's a huge investment. It goes to a cross together. One oil drill welling, what I learned from the oil industry needs almost 100 crores. When you're dumping 100 crores, it should be almost a precise to a successful. Sometimes it may fail also. Why? If the two success and three fail, it will always matching. But we need this type of a data from the reservoir geophysics, production geophysics, using a clarity images from 3D seismic, 4D seismic. Actually, when you go to the workstation, they will make it a slice at every meters and every 5 meters. See what is the pattern in it. They can take out that the slicing pattern just like our cake cutting and trying to do this analysis. So this is mainly for high resolution. Volume data permits this workstation to handle this data. So this will give you the seismographs, horizon seismographs, fault plane, and mapping. So use this primarily used for reservoir parameter field development, and also sometimes we'll use while drilling. There are a lot of hazards will take place. That hazards can also be identified with the help of the 3D and 4D. So how it is looks 3D and 4D. This is 2D data. This is 3D data. So you see the difference between these two. So how we get this the top of the surface? So this is burial top. That is burial is nothing but a subsurface concealed, and it is one of the basement. It's a hard rock here, and this may be a small pay zones. Pay zones are nothing but again you may get a hydrocarbon here. So this 3D is a more higher resolution. It contrasted to this is the drilling. They will do drill like this and trying to understand all these unit. The drilling will take place after seismic analysis. Seismic analysis. So this gives you again the refined from the decon test, velocity analysis, and 3D migration to come to a conclusion what it might have been there. Then only it goes to the production stage, quality, quantity, whether it's usable to go for exploitation or not, how much investment, how much comes. That's called economy will works out there. This another one, 3D images subsurface. You can see the properly. So migrations, say disconnected units. And you have to, as you said it, you have to see whether it's any noise has been removed. You see there is a channel cut here. In channel cut, is there any sediments? In sediments, is there any organic material? Because organic here is only the concept of formation of petroleum deposits. So identify, you see here, what we have seen in the sketches. It's on lap, off lap, and continuity. So from the edge of the surface to the subsurface, how it looks, horizontal, it is inclined. So this is 2D and 3D data. So what we are looking at, so reservoir delineation using this 3D and 4D data. That is a shape, size, thickness of the reservoir, depth of reservoir, fluid contacts. Then also we look for porosity, permeability, what type of reservoir it is, and is there any fault. So the extension, thickness, structural facies map, velocity plays a crucial analysis for depth conversion. How much depth we are looking at. Is it at 2000 meters or 3000 meters or 4000 meters? Depends on where we are encountering these type of possible occurrences. Not 100% sure till we drill. Sometimes it will be fail also. So that is where our skill and logical evaluation works out to reach to the target point. That is a estimation of hydrocarbon volumes. So again, we'll look for the porosity, permeability, and often values and making into a statistical mapping. Besides, we also try to understand any seismic evidences, seismic
Nagendra,
amplitudes.
just a brief interruption. Sorry.
Yes, sir.
If what is the 4D, what is that fourth parameter?
Which one, sir?
3D and 4D. 3D and 4D what is the fourth D? Fourth D velocity.
We will see all the dimensions, sir. Height, breadth, and we can see the slice also.
Time.
Vertical.
Time.
Time. That is time place in it. That means something related to velocity.
Yes, sir.
Okay.
So these amplitude anomalies detect gas traps, gas gaps. Estimate the volumes of maintain the oil drive, and some of the buried channels and hazards, and delineation of water sands, directly underlying reservoir for aquifer support, structural knowledge. So, and also we can find out what are the problems encounters during drilling, gas sweeps at sea bottom, buried river channels, gas pockets. So these things we are able to narrow down our information by analyzing these things. You see here, this particular unit has been put it as a gas media, gas seepages. So in 4D, as we are asking about the time, temperature, pressure, pore fluid saturations, and which will be available for the detecting of the pore pressure, velocity, density, Poisson's ratio of the rocks. And also it uses the design, the initial 3D. And while interpreting the mismatches or amplitude of 3D and 4D, two data sets, we should be very carefully to look for what we are addressing in this unit. So the SRM, that is selected reaction monitoring, fluid flow surveillance analysis, identifying the unswept oil. So you might have heard enhanced oil recovery. That enhancement, whatever the oil which is not able to exploit it, it is unswept oil, it is present there only, it is not able to take it in a normal way. So can we do it any of the enhancement oil recovery using our chemical methods? Detects high permeable zones, pathways, gas cuts, permeability barriers, structures, and the water, gas flooding, stream injections, all these can be able to identify from the unit. So reservoir characterizations, as we discussed, porosity, fluid saturation, and saturation, 4D seismic impedance inversion, and validation of reservoir simulations. So these emerging technology are interpreted for seismic, geological, petrophysical, that is a rock, physical constraints, and engineering data. Production, 4D SRM technology improves reservoir management by helping optimize productivity, infill and injection wells, utility recovery, that's UR, bypass oil, and of course the revenue approximated time actions. So these are the various techniques will be applied to use the seismic profile. Advanced techniques, analysis techniques are still many people are using. Amplitude variation with offset, amplitude versus offset, fluid identification surveillance, lithological discriminations, 4D monitoring, time lapse, production, enhanced oil recovery, seismic inversion seismics, acoustic impedance analysis, elastic parameters, P and S waves, fracture characterization. These are the advanced techniques people are working. Now the final frame of my talk. It is a versatile tool. Seismic profile delivers high resolution subsurface image across a wide range of scales and applications. Integrated approach. Maximum value is realized through multidisciplinary collaboration between geology and geophysics, technical advancement, ongoing innovations in data acquisition, processing, and interpretations. Now we have AI. Also, many doubtful information can be clarified. Continuous enhance and resolution awareness, limitations into the seismic data, achieving reliable outcome. So future outlook is emerging technology offers potential for greater accuracy, efficiency, and automation in seismic analysis. Our insight is seismic profile analysis remains a fundamental method for subsurface exploration by bridging geophysical measurements and geological insight, from which we are looking the subsurface and applying for the requirement of the specific project, either it's an infrastructure or a groundwater or petroleum deposits or environmental units. So that is about our discussion. Thank you for your attention. These are the source, and I request your 2 minutes time for next 2 slides to tell about our CAS. That is a Karnataka Association for Advancement of Sciences, which is led by our Professor Siddhappa and all other eminent scientists here. So the Karnataka Association for the Advancement of Science is housed at present. Earlier it was in the Central College, now it is at PS Engineering College. A background of this association is enthusiastic, energetic scientists of Bangalore and other part of the Karnataka, an entity to promote science and its application to snacks of national importance. Objective is promotion of science, including its applications to problems of national importance, dissemination of knowledge of science through lectures, publications, demonstrations, and exhibitions, and furtherance of scientific research. Activities are present which are doing lecture series, workshop, teacher empowerment programs, recognize young talents, recognize accomplished scientists, and trying to promote this science, because as we know, science is a process, technology is implementing. So science and engineering both should go together. Workshops on research, what, why, and how research, writing and presenting research proposals, which has been successfully done by our president at Davanagere, writing a research papers, ethics in research and publications. So teachers empowerment to go with the advancement of science, backbone of education, experimental learning, empowers teachers through training, visits, interaction, and skill development, which all of us are doing it. And so this is what we are doing it. More details of the course, come to this website and see the activities where we have multiple informations available about activities, newsletter, and news and events, and membership, how to become member. And you are welcome to course. Join us as an individual membership, institutional membership, fill in the applications online at this site. So thank you very much.
Thank you very much for a very informative presentation. Now there is time for some questions and comments. Professor Siddhappa, will start with Professor Siddhappa.
Yeah, Professor Nagendra, I compliment you for a wonderful, lucrative presentation. And I want to know what is the accuracy level with all these efforts, the technology is standing for, and what is the future hope to improve this accuracy?
Sir, accuracy is there. Normally in hydrocarbon industries, they go to the accuracy of 1 meter level. Up to 1 meter accuracy, they will try to analyze each and every seismic signals and trying to affiliate it what it is. So that is the accuracy. And in future, now this digital era has come. Now they are going 4D and large workstations and trying to look for the minute variations available in the subsurface. That is, as I told you, there is a called GeoPec with a huge software management system available in petroleum industries. So they will try to do this seismic analysis as a separate seismic wing, which they are working on this by the geophysicists. Basically, there are physicists work with the integration with the geology. They're trying to do this, and they interact with the geologist to look for, as I told you, what is the time frame, what may be available, at what depth it may be available, what condition it's available. So these analysis they're doing it. Further, they're doing various type of unit called as what we call as paleo analysis, paleo geographical maps, and already drilled wells are available with them that they're using as a reference well before they're going for a new well, so that they can able to reach to the maximum accuracy.
Okay, we'll move on. Next question. Any other questions?
Sir, in continuation of what Professor Siddhappa asked, sir, what's the prospect of using AI in seismic analysis and exploration and things like that?
Sir, at present, I am not much aware about that because AI has now only entered the industry. Now, what I heard is they are using the AI to many of these gathering what are the seismic as translated into a reality. So that trying to see the noise and other things will be easily detectable, it seems. Using AI, now we are doing various type of tests to merging, non-merging materials. That's what they're telling is they can easily separate out each signals to look for what exactly it is. At present, I am not aware about what AI's applications are doing in oil industry.
But there is still probably a possibility of using it to a large extent.
Definitely.
Yes, sir. Definitely, sir. It is going on, sir.
Any other questions?
Sir,
Nagendra.
Yes, sir.
sir, normally we discuss about the horizontal component and the vertical component of the Earth's magnetic field
Yes, sir.
naturally on the surface. For example, BH is equal to 0.38 into 10 raised to minus 4 Tesla. How about the variation of the magnetic field inside the Earth's surface or below some value? Any measurement has been done?
Sir, actually, there is a separate topic on magnetic prospecting methods
Uh-huh.
where they have done a lot of paleomagnetism. They call normal cells and reverse cells. When might have been Earth has been rotated from the what is present as north and south, how it was south and north. So these paleomagnetic reversal studies they are doing by the paleomagnetism studies. So they do at every again like a seismic. They have understood all the measurement of these magnetic anomalies from the area. We are now at present in Bombay High, where we are getting hydrocarbon is a magnetic anomaly. It's a magnetically different from the where we are getting the hydrocarbons.
Okay.
No, I have one or two questions. One of them is up to what depth can we employ this method of seismic profile analysis? What depth?
Sir, up to the success has been completed in India at the petroleum industry up to 3,500 to 4,000 meters.
3.5 kilometers. That's all.
Yes, sir. Yes, sir. Still, I think it can go with the advanced technology. At present, people are working because normally hydrocarbon has been identified at 3,000, 2,000, 3,500 meter depth below at present. At present, we have only we have 26 sedimentary basins, sir. Sedimentary basins are nothing but deep depressions in the earth crust. Subsequently, materials has been deposited over the time. So that there also we have organic world and inorganic materials that has been submerged in the subsurface due to the temperature and pressure squeezed out the organic material into lipids, whereas lipids will comes out and becomes into kerosene. The kerosene is a part of the petroleum deposits. So these basins at present only a 6 sedimentary basin has been entirely scrutinized and extracting the hydrocarbons. So there are many things to do in a different basins.
Techniques can be used for metal prospecting, metal ores seismic profile.
Metal prospecting, regarding metal prospecting, sir, we use mostly of magnetic methods for analysis. Seismic methods used to see the subsurface environment, how the environment available near the metals. So whether the metal available, how much is available, how it is dispersed, what type of material it may be. That's all. It goes with our magnetic prospecting analysis.
Thank you. Any other question?
Sir, ಇನ್ನೊಂದು question.
ಹೇಳಿ ಸರ್.
ರಿಫ್ಲೆಕ್ಷನ್ ರಿಫ್ರಾಕ್ಷನ್ ಈಸ್ ಆಲ್ ರೈಟ್. ಟ್ರಾನ್ಸ್ಮಿಟನ್ಸ್ ಅಂತಾನು ಕೂಡ ಹೇಳಿದ್ರಿ. ಅಂದ್ರೆ ಯಾವುದೋ ಒಂದು ಬಿಲೋ ದಿ ಸರ್ಫೇಸ್ ಆಫ್ ದಿ ಅರ್ತ್ ಒಂದು ಲೇಯರ್ ಅಲ್ರಿ, ಒಂದು ಪರ್ಟಿಕ್ಯುಲರ್ ಲೇಯರ್ ಮೇಲೆ ಮತ್ತೆ ಆ ಪರ್ಟಿಕ್ಯುಲರ್ ಲೇಯರ್ ಕೆಳಗಡೆ ಸೇಮ್ ಮೀಡಿಯಂ ಇದ್ದಾಗ ಮಾತ್ರನೇ ಟ್ರಾನ್ಸ್ಮಿಟನ್ಸ್ ಆಗೋದು ಅಲ್ವಾ?
ಹೌದು ಸರ್.
ಹಾಗಾಗಿ ಇರುತ್ತೆ, ಹಾಗೆ ಸಾಧ್ಯತೆನೇ ಇದೆಯಾ?
ಕಾಂಪೋಸಿಷನ್ ಇರ್ಬೇಕು ಸರ್. ಕಾಂಪೋಸಿಷನ್ ಸಿಂಪಲ್ ಆಗಿದೆ, ಟ್ರಾನ್ಸ್ಮಿಟ್ ಆಗುತ್ತೆ.
Okay, any other questions? Okay, no other questions are there. Let us thank the speaker, Dr.
Sir, one second, sir, please.
Yes, sir.
Okay.
Sir, in seismic array stations, sir, the seismometer is kept at a depth of about only few meters now, sir, few meters.
A few meters, sir, below the